Hi, I'm Terry Butchie from Ohio State University Math Literacy Initiative. We're going to talk just for a few minutes about this is just kind of general math pedagogy. Pedagogy just means how to teach math. So last week we talked about the first four, they're called math practices. That just means this is how mathematicians work. And since we want your students or your children to know how mathematicians work, then it's good for you to know the kinds of things that we're looking for and the kinds of things that we want them to be able to do and kind of just do on their own, have kind of this mathematician's kind of mindset. So last week we talked about perseverance or persevering through problems, which honestly, perseverance, I think, is one of the most important character qualities anyway, just pushing through. We're all doing that right now in our country and in our world, and we're just pushing through. We're going to persevere. And so persevering is the first one. We talked about this last week. Reasoning abstractly. That means just so you can't see it concrete as you can see it, you can feel it, you can touch it. Abstract as we have to kind of think more differently about it, and quantitatively. The third one we talked about was defending and critiquing. Defending and critiquing people's arguments. So maybe you don't want your child to know how to do that as well as they should, or as well as they need to, but we do need to be able to critique each other's reasoning in mathematics and be able to defend our own thinking about something in mathematics. And then the fourth one we talked about last week was modeling. Just talking about, putting numbers through this modeling system. We're doing a lot of modeling right now with what's happening on in the country. So they're doing a lot of mathematical modeling. So a lot of the people that we're depending on to make decisions are very competent in mathematics and other sciences as well. So those are the four that we talked about last week. This week we're going to talk about the other four. So there are 8 mathematical practices. And the fifth one, because remember we already did the 4, the fifth one is use appropriate tools. Well, we're stuck here for a little bit because we're all stuck in our homes or our apartments or condos or wherever you are placing your head at night. So we don't really have all of the appropriate tools. We talked in a previous lesson that I just did today about the fact that you can use other kinds of tools that become appropriate tools if you don't. So typically if you want to make a triangle, we would need some protractors and some compasses and some other tools that traditionally are used in a geometry class. But we can also use spaghetti for sides. We can use corners of paper to check the angle measures. Those are just more inventive kind of tools, which is what we're going to have to do while we're at home, unless if you have rulers. So in a math classroom, it would be if they want to measure the length of a room, you would want your child or student to either use a tape measure or a yardstick more so than you would just a ruler, because it would take longer. So that's like being able to choose the appropriate tool to help you out mathematically. That's what this number 5 is. Number 6 is attend to precision. So let's go back to that measurement idea that we were just talking about. If you do have a child who's doing measurement, whether it's traditional or non-traditional measurement, non-traditional is just like using items to measure something. So like using paper clips or safety pins or something. But when we do that, as tending to precision, so being as precise as we can, as exacting as we can when we're doing our mathematical work. So that's what this 6th mathematical practice is. 7 is look for and make use of structure and perspective. So I have a story about this one. My son, who is now older, he's an adult now, but when he was younger, he broke his arm. He fell out of a tree and he broke his arm, and he was laying in his hospital bed, and I was looking at something that was across from his bed, and they were, I think, gauze, different kinds of gauze. And I saw these boxes of gauze across from him. And so I asked him what number is missing. So I looked at this and I thought, clearly 1 and a 6 would be missing, or 1 and 2 6s. Or I thought maybe he would say a 3 and a 5 just to make them all even. So I asked him, and he was in the hospital, but yeah, I'm that kind of mom. So we just are always learning. So I asked him, and he said, like, quick as could be, 0 and 8. And I looked at him, and I looked at the boxes, and I, for a moment, thought, oh my goodness, what's going on? What's wrong with my son? And I said, instead of acting like that, instead of like freaking out because he didn't say 1 and 6, which is what I saw, I said, well, why do you think that? So why do you think that is always a great question to ask your child. And again, tonation is important. Well, why do you think that? So I said that, and he said, well, because our phone number, this is an old phone number, but it's not our phone number anymore. Our phone number is 5340208, and it has all those numbers except for the 0 and the 8. Which was way more complicated thinking, way more critical thinking than I had even expected him to respond with. But that's how he saw it. That's perspective. That's being able to look at something and look at different perspectives of that thing. So that's an example of that. And then the final mathematical practice is repeated reasoning. So repeated reasoning is really working with students so that they can find their own patterns and use that repeated reasoning or that pattern kind of piece to be able to discover something that they don't originally know. So I know last week the first week we put some fractions on a number line, and when we did that, there was a pattern that you could see. So remember, we had like 1/2 was here, and then we knew that 1/3 was here, and 1/4 was about here. And so I don't know if you remember me asking, but and if you weren't on that video, we were talking about, where do you think, if we didn't even put this on this number line, where do you think 1 out of 10 would be? Do you think it would be to the right or left? To the left of 1/2 or to the right of 1/2? This is a repeated reasoning question because you have to look at the data that you have and be thinking, I kind of see a pattern. Maybe you need another one to actually see the pattern. So we could do 1/8. I'm going to put 1/8 right here. So I could put 1/8 and then ask the question again, where do you think 1/10 would go? And let them figure it out and give you an answer and then justify their answer. So even if they say down here, because 10 is bigger than 2, that, they're giving their justification. Their justification makes sense to them. But then you ask them questions and you say, well, but 3 is bigger than 2, and that's on this side. Why is that? So these kinds of wonderings we want to do. You don't freak out just when your child doesn't know exactly what it is that they're looking for. They're trying to take in a lot of learning in mathematics. So let them play, let them explore, and then just let them justify what they're saying. And when they say something, so that justification, that is true, 10 is bigger than 2, but then we pose the next question, which is, okay, you use that reasoning that 10 was bigger than 2, and you pick one that is also bigger than 2, and you say, but 4 is down here, so, and 8 is down here, so what else could we look at? And then that gets you into even talking about fractions, which everyone loves to do. So just a little bit of tidbits for you when you're working with your students. We want to make sure that we don't just do the math and work with the math, play with the math, but actually play with the ideas that mathematicians use to become better at mathematics. So have a great week and hope to see you soon.